When addressing the electrical rewiring of a detached building, specifically a 3-unit structure within a motel complex, the critical aspect is the subpanel feed. The question at hand is whether a 3-wire subpanel damaged by fire should be replaced with a 4-wire system separating the grounds and the neutral conductors. The National Electrical Code, commonly referred to as the NEC, provides clear guidelines on this matter, particularly concerning detached buildings. The NEC mandates that detached buildings necessitate a separate service and their own grounding system. This implies that the subpanel within the detached building should be supplied via a 4-wire circuit, ensuring the isolation of grounding and neutral conductors. The primary reason for this separation is to maintain safety. In the event of a fault or a surge, the separation prevents current from flowing back into the main building's grounding system, which could otherwise lead to potential damage or electric shocks. If the grounds and neutral are connected within the detached building, an unintended path for current flow could be created, posing significant hazards. Specifically, NEC Section 250.32 B explicitly states that in a detached building, a separate grounding electrode system must be installed. This mandates the installation of ground rods or alternative grounding electrodes at the detached building. Refeeding the subpanel with a 4-wire circuit is essential when rewiring a detached 3-unit building. It's necessary for both safety and compliance with the NEC requirements. It is insufficient to drive grounds and bond all grounded conductors together within the detached building. Here is a more detailed explanation of the NEC requirements and the reasons behind them. Firstly, NEC Section 250.32 addresses grounding and bonding requirements for detached buildings or structures. This section emphasizes the need for a separate grounding electrode system at each detached building or structure. Secondly, the requirement for a separate grounding electrode system is primarily for safety. By having its own grounding system, a detached building can effectively manage fault currents and minimize the risk of electric shock. Thirdly, NEC Section 250.32 B specifically addresses the grounded conductor brought to the detached building. It outlines the conditions under which the grounded conductor, typically the neutral, can be connected to the grounding electrode system. In most cases, the grounded conductor must be isolated from the equipment grounding conductors at the subpanel in a detached building. Fourthly, the 4-wire system, which includes 2 hot wires, a neutral wire, and a ground wire, ensures that the neutral and ground paths are kept separate. The neutral wire carries the normal and balanced current back to the source, while the ground wire provides a low impedance path for fault currents to return to the source, tripping the overcurrent protective device. Fifthly, by separating the neutral and ground, you prevent the flow of normal neutral current through the grounding path. This is important because any voltage drop along the grounding path can create a potential difference between the grounded metal parts of equipment and the earth, which can lead to electric shock. Sixthly, when the neutral and ground are bonded together at the detached building, normal neutral current can flow through the grounding path, potentially causing objectionable current. Objectionable current can interfere with the proper operation of sensitive electronic equipment and can also increase the risk of electric shock. Seventhly, the NEC allows for an exception where the grounded conductor can be connected to the grounding electrode system at the detached building under specific conditions, such as when there is no other continuous metallic path between the buildings. However, this exception is typically limited to very specific scenarios and should be carefully evaluated by a qualified electrician. Eighthly, the size of the grounding electrode conductor, which connects the grounding electrode to the grounding busbar in the subpanel, must be sized according to NEC Table 250.66. This table provides guidance on the appropriate size of the grounding electrode conductor based on the size of the service entrance conductors. Ninthly, the grounding electrode system typically consists of 1 or more ground rods, but other types of electrodes, such as ground rings, metal underground water pipes, or concrete encased electrodes, may also be used. The choice of grounding electrode depends on soil conditions and local requirements. Tenthly, proper bonding of all metal parts within the detached building is also crucial. This includes bonding metal water pipes, gas pipes, and any other metal objects that could become energized. Bonding ensures that all metal parts are at the same potential, minimizing the risk of electric shock. 11th, all electrical work must comply with local codes and regulations, which may have additional requirements beyond those specified in the NEC. It is important to consult with a local electrical inspector or a qualified electrician to ensure that the installation meets all applicable requirements. 12th, when replacing a 3-wire subpanel with a 4-wire subpanel, it is important to ensure that the existing wiring is in good condition and properly sized for the new load. Any damaged or undersized wiring should be replaced to ensure the safety and reliability of the electrical system. 13th, the overcurrent protective devices, such as circuit breakers or fuses, must be properly sized and installed to protect the wiring and equipment from overloads and short circuits. The size of the overcurrent protective device should be based on the ampacity of the wiring and the rating of the equipment being protected. 14th, all electrical connections must be made properly and securely. Loose or corroded connections can cause overheating, arcing, and even fires. Use appropriate connectors and tools for the job, and always follow the manufacturer's instructions. 15th, after completing the electrical work, it is important to test the system to ensure that it is working properly. Use a multimeter or other test equipment to verify that the voltage and current levels are within the specified ranges. Also, test the grounding system to ensure that it is providing a low impedance path for fault currents. 16th, documentation is essential for any electrical work. Keep a record of all work performed, including the materials used, the test results, and any deviations from the NEC or local codes. This documentation can be helpful for future troubleshooting or maintenance. 17th, safety should always be the top priority when working with electricity. Always de-energize the circuit before working on it, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the job. 18th, regular maintenance is important to ensure the continued safety and reliability of the electrical system. Inspect the wiring, connections, and overcurrent protective devices regularly and address any problems promptly. 19th, consider the specific requirements for a motel environment. Hotels often have unique electrical demands due to the presence of multiple units and common areas. Ensure that the electrical system is adequate to handle the load and that all wiring and equipment are properly protected. 20th, it is important to understand the difference between grounding and bonding. Grounding provides a path for fault currents to return to the source, while bonding ensures that all metal parts are at the same potential. Both grounding and bonding are essential for electrical safety. 21st, when working with older electrical systems, it is important to be aware of potential hazards, such as asbestos, insulation, or lead paint. Take appropriate precautions to protect yourself and others from these hazards. 22nd, the NEC is updated every 3 years, so it is important to stay current with the latest changes. Consult the latest edition of the NEC for the most up-to-date requirements. 23rd, consider the use of arc fault circuit interrupters, commonly known as SIs, to provide additional protection against electrical fires. SIs detect arc faults, which are a common cause of electrical fires, and trip the circuit breaker to de-energize the circuit. 24th, surge protection is also important to protect sensitive electronic equipment from damage caused by voltage surges. Surge protective devices, commonly known as SPD, can be installed at the service entrance or at individual outlets to protect against surges. 25th, ensure that all electrical boxes are properly supported and secured. Electrical boxes should be mounted in a way that prevents them from moving or vibrating, which can damage the wiring and connections. 26th, when running wiring through walls or ceilings, use appropriate wiring methods to protect the wiring from damage. Use conduit or other protective measures to prevent the wiring from being punctured or damaged by nails, screws, or other objects. 27th, label all circuits clearly and accurately. This will make it easier to identify the circuits in the future and can prevent confusion when troubleshooting or making repairs. 28thly, consider the use of energy-efficient lighting and appliances to reduce energy consumption and lower utility bills. LED lighting and Energy Star appliances can save a significant amount of energy over time. 29thly, it is important to understand the local climate and environmental conditions when designing and installing an electrical system. In areas with high humidity or corrosive environments, use wiring and equipment that are specifically designed for those conditions. 30thly, remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. If you are not comfortable working with electricity, hire a qualified electrician to do the job. In summary, for a detached building with a subpanel, always use a 4-wire feed to maintain separate grounding and neutral paths. This adheres to NEC guidelines and ensures a safer electrical system by preventing unintended current flow through grounding paths and minimizing the risk of electric shock. Always consult the latest NEC edition and local codes for the most accurate and up-to-date requirements, and prioritize safety in all electrical work.